Hello, sleepy thinkers, and welcome to Sleepy Science Teller. Tonight, we'll drift into a question that has fascinated dreamers, philosophers, and scientists alike. What if you could freeze time? Just imagine the world around you completely still, the air unmoving, the clock frozen mid-tick, and every sound suspended like a delicate note that never fades away. But before we explore this dreamy mystery, I'd love to know, where are you listening from tonight, and what time is it right now in your part of the world? Share it in the comments below. I always enjoy knowing where in time and space you are, and if you find peace in gentle discoveries like this one, please take a quiet moment to like this video and softly subscribe so you can join me again under the sleepy stars for another bedtime exploration. Have you ever wished that you could stop time just for a moment, to pause the spinning of the world, to hold everything perfectly still? It's a dream many of us share, though few admit it out loud, a wish that rises quietly on tired evenings when the world feels too fast, when the seconds rush by like grains of sand slipping through open fingers. Imagine standing in the middle of a crowded street, cars frozen mid-turn, people pause in mid-step, raindrops suspended in the air, tiny jewels glimmering around you, the world unmoving, silent, only you, aware, breathing in the stillness. That image alone feels magical, doesn't it? It carries something deep and ancient, a longing to control what cannot be controlled, to hold on to a single perfect moment and never let it fade. We've all felt time slip away from us. When we're happy, time feels short. When we're sad or waiting, it stretches endlessly, but it always moves, always flows forward. And so, the idea of stopping time is more than just curiosity. It's a reflection of our inner wish to find peace, stillness, and control in a universe that never stops moving. Throughout history, the idea has appeared again and again in myths, in literature, in films. The Greeks imagined gods who could pause the heavens. In medieval stories, wizards held the power to freeze entire kingdoms. In modern movies, heroes click their fingers and halt reality itself. Yet underneath these fantasies lies a deeper question. What is time, really? Why does it move? And what would it mean to stop it? Before we dive into the science, let's rest for a moment and feel what time means inside our own lives. Close your eyes for a second and think of a memory that you never wanted to end. Maybe it was a sunset, glowing gold across the sky, or the laughter of someone you love. In that instant, did it feel like time slowed down? Like everything outside that moment faded away? That feeling is the emotional truth behind our wish to stop time. It's not about physics or power. It's about presence. It's about wanting to stretch the beauty of now into forever. But what if, beyond emotion, beyond fantasy, we could actually understand what stopping time might mean scientifically? Would it be possible? Or would the act itself undo everything we know about existence? To find out, we need to explore the heart of what time is, how it flows, how it defines change, and why stopping it would shake the universe itself. Before we do, let's linger a little longer in imagination, because imagination is the bridge between wonder and knowledge. Picture this. You're walking through a forest late in the afternoon. Sunlight filters gently through the trees, golden and soft. You reach out your hand, and suddenly everything stops. The leaves freeze mid-fall. The air hangs like glass. Your footsteps echo once, then fade into perfect silence. Even your shadow stops moving. At first, it feels peaceful, almost divine, a quiet world, untouched by time. But then, a strange realization creeps in. Without time, nothing can move. Not the wind, not your heartbeat, not even your thoughts. That's when it hits you. Stopping time might not mean peace at all. It might mean the end of everything. And yet, the dream still lingers. Because deep down, what we seek is not the freezing of moments, but the slowing of life, long enough to feel it fully. So, as we begin our exploration, we'll look gently at what time truly is, how it shapes motion, matter, and thought, and what the idea of stopping it reveals about the universe and about ourselves. To understand what it means to stop time, we first need to understand what time is. In everyday life, we see time as something simple, seconds ticking on a clock, days passing into nights, years turning into memories. But science tells us that time isn't a separate thing, flowing like a river beside us. It's woven into the very fabric of the universe, connected to space itself, forming what we call space-time. Imagine stretching a blanket across a table. Now place a small ball on it. The blanket curves gently downward. That curve represents gravity, and time flows differently along that curve. When Einstein described this over 100 years ago, he changed everything we knew about reality. He showed that time doesn't move at the same speed for everyone. A person near a strong gravitational field, like a planet or a black hole, experiences time more slowly than someone far away in deep space. So, already, the idea of freezing time becomes complicated. Time is a switch you can turn off. It's a part of everything. Every atom, every star, every heartbeat. If time stopped, all motion would stop. If all motion stopped, atoms would freeze, light would halt, energy itself would no longer flow. The universe would fall silent. But here's the beautiful irony. In our minds, we can imagine this impossible stillness. And imagination is not bound by physics. When we dream of stopping time, we step briefly outside the laws of nature into the realm of wonder. Many thinkers have wrestled with this paradox. The philosopher Augustine once said, "What then is time? If no one asks me, I know. If I wish to explain it, I know not." That mystery remains even today. Physicists can describe how time behaves, but not why it exists. So, when we wish to stop time, perhaps we are trying to reach for something beyond the limits of science, a moment of pure being, where nothing changes, nothing fades, and yet everything feels eternal. Now let's imagine a world. If you truly could stop time, every moving thing from the turning earth to the spinning of electrons would halt instantly. The air itself would stop flowing. Sound would vanish because sound needs vibration. Light would freeze mid-journey, unable to reach your eyes. To you, that world would be absolute darkness and absolute silence. But there's more. Even your body would stop working. Your heart would freeze mid-beat. Your neurons would no longer fire. You wouldn't think or even know that time had stopped. So, the moment you stop time, you stop awareness too. And with no awareness, no experience remains. It's strange, isn't it, that our most magical dream, when examined closely, becomes impossible even to perceive. But there's another way to think of it. Perhaps Stopping time isn't about halting the universe, but about slowing ourselves until the world around us feels still. Have you ever sat quietly at dawn when the air is cool and everything feels suspended as if the earth itself is holding its breath? That's as close as we can come to freezing time, not by breaking physics, but by calming our own rhythm. In those moments, the heart and the mind fall into harmony, and time seems to lose its hold. That is the stillness we seek, and perhaps the stillness that nature allows. So, while we may never truly freeze time, we can discover pockets of eternity, hidden within the flow of every second, moments that feel infinite because in them we are fully alive. The idea of stopping time, then, is not a question of science alone. It's a whisper from a human soul, a longing to rest, to pause, to simply be. And in that sense, maybe we already can freeze time, not with machines or magic, but with presence, with awareness, with stillness. Because when you are fully here, fully now, time stands beautifully still. Imagine standing beside a quiet river, its surface gleaming silver under a pale morning sky. The water drifts gently by, never rushing, never stopping, just flowing endlessly onward. That's time in its purest metaphor. A river that carries everything, every sound, every breath, every heartbeat, from what was toward what will be. We stand on its banks, watching memories float behind us and possibilities shimmer ahead. But the current never stops. The ancients felt this truth long before clocks existed. They watched the sun rise and fall, the tides come and go, and they saw the rhythm of life itself. They called it Chronos, or Kala, or Zaman. Different names, same mystery. Time is a river, flowing through everything that lives and changes. When we try to hold the water in our hands, it slips away, just as moments do. You cannot keep it. You can only feel it as it passes. Pause for a moment. Listen to the quiet hum of your own life, your breathing, the faint ticking of a clock, the sound of distant motion. That's the river moving through you. Science, too, has fallen in love with this idea. Physicists describe time as a dimension, not just something we move through, but something that shapes the very structure of reality. Einstein called it the fourth dimension. He said space and time are interwoven, like threads in a single fabric, stretching, bending, curving under the weight of stars and planets. When that fabric moves, time moves. When it stretches, time slows. When it compresses, time speeds up. So when we say time flows, we're not just speaking in poetry. We're touching something deeply real. The entire cosmos is this river. Every atom swims in it. Every star, every human, every dream floats downstream. But unlike an ordinary river, time has only one direction. It moves forward, never back. We can travel through space in any direction we please. But time carries us like a current, always onward. Why? That question has puzzled science for centuries. It's called the arrow of time. The arrow points one way. Because of entropy, the gradual spreading of energy, the universe's way of moving from order to disorder. As things change, energy disperses, heat flows, and the story unfolds. That unfolding is time. So the next time you watch a candle burn or an ice cube melt, you're watching time's river flow. You're watching the arrow move forward, never in reverse. Even memory itself is part of that current. We remember the past, but never the future, because memory, too, is built into time's direction. The river moves, and we move with it. And maybe deep down, we are that river. Close your eyes for a moment and imagine yourself standing in that same river again. But this time, you're underwater. The current brushes past your skin. Soft, unstoppable, a constant whisper. You can't escape it, but you can float with it or fight against it. That's how life feels, doesn't it? Some days, we drift effortlessly with time's rhythm. Other days, we push against it, trying to go back, trying to relive a moment or undo a choice. But the river never turns. That's why the image of time as a river is both comforting and humbling. It reminds us that everything changes, everything moves, and nothing ever stays perfectly still. Even the mountains, those ancient giants of stone, are slowly crumbling under time's touch. Even stars, those bright eternal fires in the sky, live, age, and fade. Every atom in your body was once part of an ancient star that lived and died long before Earth existed. You are made of recycled time. The river has flowed through you for billions of years. In this sense, you've always been here. You were part of the universe long before you open your eyes, and you'll remain part of it long after your story folds back into the current. Time's river doesn't destroy. It transforms. The drop of water that reaches the ocean is never truly lost. It becomes part of something larger. And so, the passing of time isn't something to fear. It's the way the universe breathes. Scientists studying relativity discovered that time is flexible, not like a ticking clock, but like a living stream. If you move faster, time slows down for you. If you rest in gravity's pull, time bends differently. That's not imagination. It's been measured, proven. Astronauts orbiting the Earth experience time just a tiny bit slower than we do here. They return a few milliseconds younger, a faint ripple in the river, but real. When Einstein realized this, he understood something beautiful. Time is not universal. It's personal. Each person, each planet, has their own unique flow. So maybe every life is its own small river, running alongside others, meeting, diverging, and joining again in the sea of existence. Think about that as you breathe in slowly and let your thoughts drift downstream. Now let's go deeper still. What would it mean to step out of the river of time? To watch it flow while standing completely still. Some philosophers believe that's what happens when we meditate or dream. When the mind becomes quiet, time seems to lose its grip. You felt it before. That strange sensation when you look up at the stars, and for a moment, you forget what hour it is, or even what day. There's just now. In that now, the river slows, and you float in its center, perfectly at peace. That's not science, perhaps, but it's deeply human, because time isn't just an external measure. It's an inner experience. When we're anxious, it rushes. When we're joyful, it flies. When we're calm, it glides gently by. So maybe the flow of time isn't fixed at all. Maybe it bends with consciousness. Modern neuroscience has even begun to explore this. When people meditate deeply, their brain's internal clock slows down. Perception changes. Seconds stretch, and awareness deepens. In that state, time really does feel like a river, smooth, unhurried, eternal. And here's the most poetic part. Every river begins somewhere. A tiny spring, high in a hidden place, where water first touches a world. Time, too, may have had a beginning. Physicists call it the Big Bang, the moment when everything, including time itself, began to flow. Before that, there was no before, no moment to count, no ticking, no motion, no existence. From that first ripple, time spread outward, filling galaxies, stars, and lives. And someday far in the future, the river may reach its ocean, a still, timeless sea where the flow fades into peace once more. Until then, we drift through laughter and sorrow, through learning and love. Each moment we live is a small drop added to the great current. So perhaps time is an enemy to be fought, but a friend to be understood. It doesn't steal from us. It carries us gently onward, and in its flow we find meaning. Because in truth, we are the river. We are time, dreaming of itself. Close your eyes and notice the ticking of time. Maybe you hear a clock somewhere in the distance, steady, patient, each second falling like a drop of rain. But if you really listen, you'll realize that the clock isn't what measures time for you. It's your mind interpreting the rhythm, translating change into meaning. Our perception of time isn't something fixed or external. It's a living, shifting experience built deep within our brains. Think of moments when time felt strange, when you were a child and a single day felt endless, when you waited for someone you loved and each minute stretched forever, or when you laughed with friends and hours vanished in what felt like seconds. In those moments, nothing outside you changed. Only your mind's rhythm did. Scientists have studied this curious thing called subjective time. They found that the human brain doesn't actually measure seconds the way a clock does. Instead, it keeps time by observing patterns, motion, sound, sensation, and emotion. When the world around you changes quickly, your brain processes more information, and that flood of experience makes time feel longer. That's why, during danger, a moment can seem to unfold in slow motion. The brain records every detail, expanding a single heartbeat into what feels like eternity. But in peaceful moments, when little changes and the world feels safe, the brain relaxes its attention and time flows more smoothly. That's what you're feeling right now, as the words drift slowly across your thoughts. A gentle sense that time is soft, unhurried, safe. Philosophers have written about this for centuries. Augustine long ago said, "I know what time is until someone asks me," because the moment we try to define it, it slips away, like a dream fading on waking. Psychologists, too, have tried to measure time perception. They ask people to guess how long a light shines, or how long a tone lasts. But the answers always vary, from one moment, one emotion to the next. Fear lengthens time. Joy shortens it. Boredom stretches it like taffy. Excitement folds it like paper. So perhaps the real clock is made not of gears and springs, but of feelings. Your emotions are the hands of your inner watch. Your attention is its heartbeat, and the more present you become, the slower that heartbeat feels. Try it now. Take a slow breath in and a soft breath out. Listen to how the air moves in and out of your lungs. Notice how, for a moment, time stops rushing and begins to glide. That's perception, shifting the pace of the universe inside your mind. The human brain has tiny structures that help it sense time. the basal ganglia and the cerebellum, neural circuits that fire in rhythmic patterns, tracking change like silent metronomes. But they don't tick perfectly. Their rhythm is affected by attention, emotion, and even body temperature. When you're excited, adrenaline speeds your internal clock. Your mind takes in more frames per second, and moments appear to slow down. When you're relaxed or tired, the brain takes fewer snapshots, and time seems to slip past more quickly. That's why childhood feels long. Children's minds are new, absorbing every color, sound, and sensation. Each day is filled with novelty, so their internal clocks tick fast, and their sense of time stretches wide. But as adults, life becomes familiar. The brain stops recording so many details. It compresses experience, and years seem to rush by. It isn't that time changes. It's that our perception smooths the flow. To test this, neuroscientists place volunteers in dark rooms, deprived of sound, light, and motion. When they emerged, some thought minutes had passed. Others swore it was hours. Their brains, without signals to anchor time, simply drifted, creating their own rhythm. This shows us something profound. Time for us isn't just external. It's embodied. Every heartbeat, every breath, every blink becomes a tiny drum in the orchestra of perception. And when that rhythm changes, our sense of time bends with it. Think of an athlete in perfect motion, a dancer, a musician, a pilot in flight. They speak of entering the zone, a state where time seems to vanish. That isn't magic, it's synchronization. Their body and mind move as one, so the usual awareness of time dissolves. In meditation, the same thing happens. Brain waves slow, breathing deepens, the mind releases its constant counting. Time becomes less of a measure and more of a feeling, an endless, flowing present. In such a state, 1 minute or 1 hour feels the same. There is no hurry, no past or future, only being. And maybe that's what the dream of freezing time truly is, not a wish to stop the universe, but a longing to stop the inner clock, to step into a timeless awareness. Because when we are fully present, fully here, time cannot hurt us. It simply flows around us like a gentle stream. Now, let's drift into the science behind illusion. There's a fascinating experiment called the chronostasis effect. When you glance quickly at a clock, the first second often seems longer than it really is. Your brain freezes at instant, stretching it unconsciously to stabilize what you see. It's as if the mind itself creates a miniature pause in time. Another phenomenon, called the oddball effect, shows how unexpected events stretch time. When something surprising happens, a sudden sound, a flash of light, your brain devotes extra attention to it. That focus slows your internal perception. Time seems to dilate, making danger or novelty feel longer than calm moments. So perception of time is deeply linked to attention. Where attention goes, time flows differently. It's almost poetic. We don't live inside time. Time lives inside us. Our memories, too, distort time's rhythm. When we recall the past, we recreate it, not as it was, but as it felt. Moments of emotion glow brighter and longer in memory. Moments of routine fade more quickly. That's why entire years can seem to blur into one short breath, while one golden afternoon can stretch across a lifetime. Time perception also ties to aging. As we grow older, each new year becomes a smaller fraction of our lived experience. To a 10-year-old, a year is 1/10 of life. To a 50-year-old, it's 1/50th. The brain unconsciously scales experience, and time seems to accelerate. But even here, we can slow it, not by stopping the world, but by renewing our sense of wonder. Every time we learn something new, travel somewhere unfamiliar, or notice details we once ignored, the inner clock expands again. Moments feel larger, richer, more alive. So maybe to slow time, we must first open our eyes. Pay attention to the sound of the wind, to the way sunlight flickers on a wall, to the small heartbeat of life that never stops. Because attention is awareness, and awareness creates eternity. In the quiet depths of perception, you may find that time itself is an illusion, a rhythm your mind composes, so that you can dance within existence. And if you listen carefully, beneath the ticking of the clocks, you might hear another sound, a slow, endless hum, the music of being. That is the true perception of time, not the numbers, not the seconds, but the feeling of being alive within the flow. Imagine for a moment a world perfectly still, no breeze moving through the leaves, no ocean tide rising or falling, no atoms vibrating, no light traveling through space. A frozen universe. It's difficult, isn't it, even to picture it? Because everything we know, everything we are, depends on motion. Motion is the heartbeat of existence. It is a language through which time speaks. From the cosmic dance of galaxies to the trembling of an electron around a nucleus, motion defines reality. Without it, time would not just stop, it would vanish. When physicists describe motion, they speak of change over time. Velocity, acceleration, inertia. These are not just numbers. They're descriptions of how matter moves within the flow of time. But what if we try to reverse that equation? What if time itself only exists because of motion? If nothing ever moved, if no atom shifted, no photon pulsed, no neuron fired, then no change could ever be observed. And without change, what meaning would time even have? The ancient Greeks wondered about this. Zeno of Elea, a philosopher of paradoxes, asked how motion was even possible. He imagined an arrow flying through the air and said, at any single instant, the arrow is still. It occupies one place, frozen in that infinitesimal moment. So how does it move? If every instant is frozen, how can motion emerge from stillness? The paradox baffled thinkers for centuries. But what Zeno revealed, even without knowing it, was that motion and time are inseparable. You cannot have one without the other. Modern physics later resolved this mystery through calculus, through the concept of continuous change. Motion is not a sequence of still frames. It's a smooth unfolding, an unbroken ripple across space-time. Every object, every atom, is forever in motion. Even you, as you sit or lie still right now, you are moving, spinning gently with the Earth's rotation, hurtling around the sun, drifting through the Milky Way at thousands of kilometers per second. Stillness is an illusion of perspective. Even within you, your heart beats, your blood flows, your cells vibrate, your atoms dance. Stillness on every level is simply motion too small to see. When we speak of freezing time, what we're truly imagining is a universe where motion stops. But if that were to happen, nothing would be visible, because seeing requires photons moving into your eyes. Nothing could be felt, because touch depends on atoms colliding. Sound would not exist because air molecules must move to carry it. A frozen world would be pure silence, pure darkness, pure non-existence. And yet, in our imaginations, we still wonder what that stillness would feel like, as if the very act of dreaming about it is our way of touching eternity. To truly understand motion, we have to step into the language of physics, a language written not in words, but in relationships. Newton once said, "Motion is relative to the observer." Every movement depends on another point of reference. If you stand on a train and toss a ball straight upward, it seems to move only up and down. But to someone watching from the platform, the ball travels in a graceful arc, a curve through both space and time. This relativity of motion tells us something profound. Movement is not absolute. It exists only as comparison, as difference between one thing and another. That means time, too, is a kind of comparison. We measure it by the motion of hands on a clock, by the swing of a pendulum, by the vibration of cesium atoms in atomic clocks. All our clocks are really motion detectors. Every tick is a movement. Every second is a change. Remove motion, and every clock in the universe would fall silent. In the quantum world, motion behaves even more strangely. Particles do not travel smoothly from one place to another. They exist in probabilities, in shimmering clouds of possibility. An electron doesn't move around the nucleus in the way a planet orbits a star. It appears in one place, then another, its position spread across space until measured. That means at the tiniest scale, motion itself is not continuous. It is probabilistic, a flicker between existence and uncertainty. And if you think about it, that flicker, that constant shift, is what gives rise to everything solid, everything real. Without motion, atoms wouldn't form bonds, molecules wouldn't exist, stars wouldn't ignite, life wouldn't breathe. Motion is the architect of time, and time is the rhythm of motion. They are one. Imagine the universe as a grand symphony, and motion as the music being played. Time is the melody we hear, the way the notes unfold. Without motion, there will be no sound at all, no rhythm, no harmony, no experience. So to freeze time, in a physical sense, would be to silence the entire cosmic orchestra. Even light itself, the fastest thing we know, is pure motion. Photons are energy in transit. If motion ceased, light would vanish, and with it, all sight. A motionless universe would not be a frozen image. It would be nothingness, because even the image requires light to exist. And so, when you picture everything frozen, you are actually picturing something that can never be seen, a concept beyond experience, the ultimate paradox of motion and stillness. Let's return for a moment to our own human scale, to the quiet dance of motion within you. Your heart beats around 100,000 times a day. Each beat sends a pulse through 60,000 miles of blood vessels. In that pulse is time itself, a biological clock, measured not in seconds, but in rhythm. Every cell, too, has its cycles, its internal oscillations. Proteins fold, unfold, refold, each act guided by temperature, energy, and motion. Your entire being is a choreography of motion, and yet we crave stillness. We long for that frozen, perfect moment, when nothing moves, nothing changes, and we can rest. But physics whispers a different truth. Stillness, it says, is not the absence of motion. It is balance. It is a point where forces cancel out, where the energy of motion is perfectly distributed, even at absolute zero, the coldest possible temperature. Atoms never stop moving completely. Quantum mechanics tells us there is always zero-point energy, a faint hum that cannot be erased. Motion is eternal. It is woven into the fabric of reality itself. So when we imagine freezing time, what we're really seeking is not to stop motion, but to slow our perception of it, to feel the world's rhythm at a gentler pace. That's what happens when you watch raindrops slide down glass, or waves roll softly toward the shore, or leaves sway under a calm wind. For a brief instant, you align with motion instead of racing against it. You become part of the flow. That feeling, that deep serenity, is perhaps the closest a living being can come to the illusion of frozen time, because in that harmony, motion and stillness merge. Time ceases to chase you and begins to breathe with you. And if you listen closely now, you can feel that rhythm within your pulse, within your breath, within the slow turning of the earth beneath your feet. That is the physics of motion, a universe forever in dance, forever alive. Close your eyes for a moment and imagine the air around you. It seems still, doesn't it? Calm, motionless, peaceful. But within that stillness, countless trillions of particles are in ceaseless motion. They spin, vibrate, collide, and drift, bouncing softly against one another, a never-ending ballet, unseen but unbroken. Every breath you take is filled with this invisible motion. Every object you touch is vibrating quietly. Even the most solid stone or metal, at the atomic level, there is no stillness, only energy and motion. An atom is mostly empty space, a tiny, dense nucleus surrounded by electrons, whirling in probability clouds. Those electrons never rest. Their positions blur between what is and what could be, and within that blur, time flows. Physicists often describe time as a measured change, and change is born from motion. When atoms move faster, time seems to flow differently. When they slow down, when motion nearly ceases, time stretches and loses definition. Temperature itself is simply a way to measure atomic motion. The warmth you feel right now is a gentle vibration of molecules against your skin. Coldness, on the other hand, is simply less motion. Atoms slowing, losing energy, settling closer together. And at absolute zero, the coldest possible temperature in the universe, atoms stop moving almost entirely. Almost, but not completely. Even there, in that ultimate stillness, tiny fluctuations remain. A soft hum called zero-point energy. It is the whisper of quantum uncertainty, the rule that even at perfect cold, some motion must exist. It is as if the universe itself cannot bear to be perfectly still. If you could somehow slow every atom, freeze them perfectly in place, you would not just stop motion, you would stop time, because time at its deepest level is the unfolding of atomic change, the ticking of a clock, the beating of a heart, the orbit of a planet. All are just echoes of atoms moving, colliding, vibrating. When we say a second has passed, what we truly mean is a certain number of vibrations have occurred. Even the most accurate clocks, atomic clocks, measure time by counting the oscillations of cesium or rubidium atoms. Each vibration is a pulse of time itself. Stop the vibrations, and time disappears. So in a strange and beautiful way, the flow of time is tied to the rhythm of the tiniest things. Every instant you experience is anchored to the motion of atoms, humming quietly in the fabric of your reality. And though we cannot see them, their endless motion creates everything you know: sound, heat, light, touch, and life. It is a reminder that beneath every still surface lies a universe in motion. Let's journey deeper into this hidden motion that makes time real. Imagine holding a small piece of metal in your hand, cool and solid. If you could zoom in far enough, you would see that every atom inside it is vibrating wildly, jostling against its neighbors, their energy creating the sensation of temperature. Now, imagine that metal slowly cooling, the atoms calming, their vibrations weakening, the entire structure tightening like a deep breath being held. As the temperature drops, the atomic motion slows, and with it, the very pace of time within that object seems to slow as well. This isn't just imagination, it's physics. In superconductors, when materials are cooled near absolute zero, electrons begin to move in perfect harmony, losing all resistance. It's as if the material enters a state where ordinary rules dissolve, and motion becomes eternal and effortless. This phenomenon hints at something profound about time, that the way atoms move can bend the way we perceive its flow. If you could freeze every atom in the universe, you wouldn't just stop motion, you would erase the possibility of change. No chemical reactions could occur, no light could travel, no thoughts could form. Time itself would fade into silence. In quantum theory, atoms are never truly at rest. They exist as waves, fluctuating even in emptiness. That constant trembling, that shimmering uncertainty, is what allows existence to continue. If atomic motion stopped entirely, the quantum field itself would collapse. Reality would lose its texture. Matter would dissolve into a still, dimensionless void. So when we say, what if we could freeze time, we are really asking, what if we could stop the dance of atoms? And the answer is hauntingly simple. Without that dance, the universe would vanish, like a dream at the moment of waking. But here's the quiet wonder in it all. You are made of this atomic music. Every heartbeat, every thought, every flicker of awareness depends on countless atoms in motion. The warmth of your skin, the spark in your neurons, the pulse of your blood, all are born from vibrating particles that have been dancing since the dawn of creation. So the next time you sit in silence and the world seems still, remember that beneath that calmness is a storm of motion, a symphony of atoms, keeping time with the universe itself. Now let's drift into the most intimate connection of all: how atomic motion shapes your own personal time. Your body is a living clock. Every cell, every molecule operates in cycles, tiny biochemical rhythms, driven by molecular motion, your circadian rhythm, the internal clock that governs sleep and wakefulness, is built from chemical oscillations within the neurons of your brain. Proteins activate, deactivate, rise and fall in concentration, in repeating patterns of motion. When these molecular motions align with the rhythm of the Earth's rotation, day and night, your body feels balanced, and time feels natural. When they fall out of sync, when you stay awake too long, or travel across time zones, that rhythm falters. Time feels blurred, as though the atomic harmony within you has lost its beat. The way you experience time is therefore deeply tied to the motion of atoms inside you. Every emotion, every thought, every memory depends on electrical signals, tiny bursts of moving ions traveling along neurons at precise speeds. When those signals slow, time seems to slow. When they race, time feels faster. So time is not just something out there flowing past you like a river. It is something within you, woven into your biology, constructed from the rhythm of atoms. And when you sleep, when you drift between waking and dreaming, those atomic rhythms soften. Your heart slows, your breath deepens, your neurons whisper instead of shout. It is in that softness, that near stillness, that you come closest to understanding what frozen time feels like. Not a halt in existence, but a suspension, a slowing, a surrender, a perfect balance between energy and calm. The atoms still move, but they move gently, as though swaying to a lullaby. And in that state, the boundaries between seconds begin to blur. Moments stretch, dreams unfold, and you feel timeless. So perhaps the secret to freezing time is not to stop motion, but to move with it so gracefully that you no longer notice its passing, to become one with the quiet hum of atomic motion itself. That is where time slows and peace begins. Let's imagine something impossible. You raise your hand, and with one quiet thought, you stop the world. The air halts mid-breath. Waves pause in the middle of their fall. Clouds hang suspended in the blue stillness of the sky. Every leaf, every raindrop, every heartbeat on earth, frozen in perfect silence. It sounds peaceful, doesn't it? Like a world caught in crystal. A perfect pause. A breath that never ends. But what would really happen? If you could stop time, would you see everything perfectly still, like a pause video? Would you move freely among the frozen world, able to explore while everyone else remains still? That's what imagination loves to picture. But science whispers something different, because freezing time is not just stopping motion. It is stopping everything that makes reality possible. If time truly stopped, light would stop moving, too. That means no photons would enter your eyes. You would see nothing, not darkness exactly, but the absence of all perception. No sound would reach your ears, because air molecules would no longer vibrate. No breath could be drawn, because oxygen would no longer flow into your lungs. Your body, your atoms, would also be frozen. Your heart wouldn't beat. Your brain wouldn't fire. Your thoughts would vanish mid-spark. To freeze time completely is to erase the possibility of existing within it. And that's the paradox. To experience frozen time, you must still be moving, still existing within some layer of motion. But the moment motion exists, time exists with it. So to stop time entirely would mean you could never know what happened. If you froze the universe, you would freeze yourself too. No awareness, no sight, no memory of the stillness. You could only imagine it after time had started again. That's the freezing paradox. The impossibility of stopping time, without also stopping the one who observes it. It's a concept that sounds simple, yet hides one of the most profound truths about existence itself. You can only know stillness, while time continues to flow. Let's drift deeper into this paradox. When you watch a movie and hit pause, the image on the screen freezes. A single frame, motionless, but the device holding that image still runs. Electricity still flows. Pixels still hold their light. The world around it keeps moving. The pause is an illusion within a greater motion. That's the only kind of frozen time that can truly exist. Something must remain moving to witness the stillness of something else. In physics, this is called reference. You can only measure motion or time in relation to another thing. So if everything stopped, all atoms, all light, all energy, there would be nothing left to define what stopped even means. A pause has meaning only when something else continues. This realization ripples through the deepest levels of science. Einstein's relativity tells us that time and space are woven together. They stretch and bend with motion, but they can never completely tear apart. If you tried to freeze time, you'd also have to freeze space. And with that, you'd freeze energy itself, and reality would collapse into still nothingness. It's not just that the world would stop moving, it would cease being. And yet, our minds continue to imagine this impossible stillness, maybe because we long for it. The human heart, caught in the rush of clocks and noise, aches for silence, for that eternal, unmoving peace, where the chaos of existence finally rests. So we invent stories about freezing moments, pausing life, holding on to a second so perfect that it never fades. And though it can't happen in physics, it can happen in perception. There are moments in life that feel frozen, moments where awareness deepens, where everything seems to slow, and time loses its urgency. The first snowfall of winter, the hush before dawn, the stillness of a loved one's hand in yours. For those few breaths, the world feels timeless, not because time has stopped, but because your mind has aligned so perfectly with the present that it no longer reaches for what's next. In that harmony, you touch the illusion of frozen time, not through control, but through surrender. Now let's look at the freezing paradox through another lens, that of thought itself. Imagine your brain as a vast network of electrical signals, neurons firing in patterns that create awareness, memory, and feeling. Each firing, each spark represents motion, ions moving across membranes, electrical currents flowing through matter. That motion is consciousness. If time were frozen, that motion would stop, and your awareness would vanish. You wouldn't see the stillness. You wouldn't be to notice it. That's the paradox in its purest form. To perceive stillness, you must remain in motion. And so, what we truly seek is not to stop time, but to find peace within its movement. You can't escape the river, but you can float gently upon it, without resistance, without fear. The act of being fully present, of breathing slowly, of noticing the quiet rhythm of your body, creates a sensation much like frozen time. Everything continues to move, but your mind becomes still enough to feel as if it isn't. That's what meditation and even sleep secretly offer us. A controlled freezing of perception, a peaceful surrender to the movement beneath awareness. Time keeps flowing, atoms keep vibrating, but you become weightless within it. That is the gentle secret behind the paradox. That true stillness exists not in stopping time, but in letting go of your need to control it. When you do, you find that timeless peace you've been searching for, not beyond motion, but within it, because time, in all its unstoppable flow, isn't your enemy. It's the breath of the universe. And you are part of that breath, a single precious ripple in the infinite motion of all things. So when you next wish to freeze time, perhaps simply pause and feel it instead, the soft hum of atoms, the gentle beating of your heart, the whisper of your breath. Each is proof that you are living within the paradox, moving, yet still. Time, we live inside it, move through it, and are shaped by its endless current. But time, as it turns out, is not what it seems. Einstein once said, "Time and space are not separate realities. They are two sides of the same fabric." A statement so quiet, so simple, and yet it rewrote the story of the universe. For most of human history, we believed time was absolute, an invisible river flowing everywhere at once, with perfect unchanging speed. 1 second for you, 1 second for me, 1 second for every star in the sky, all ticking in harmony. That was the old truth. But Einstein saw deeper. He realized that the flow of time depends on motion and on gravity itself. That time could stretch, could bend, could even slow to a crawl when touched by massive objects or extreme speed. And so began a new kind of understanding, one that made time feel almost alive. You are standing still on Earth, watching a spaceship glide by overhead. To you, it seems to move fast, perhaps close to the speed of light. Inside the ship, a clock ticks steadily. To the traveler within, everything feels normal. But to you, watching from the ground, that same clock ticks slower. The faster the ship moves, the slower its time runs, relative to yours. This is not an illusion. It is not perception. It is real, and it has been proven again and again in particle accelerators, in satellites, in the very GPS systems guiding our phones. The universe, it seems, has no single universal now. Each observer carries their own rhythm of time, woven into their journey through space. That's why we call it space-time. Not space and time, but one continuous entity, where motion through one changes how you experience the other. If you move through space more quickly, you move through time more slowly. You trade one kind of motion for another, and in that exchange lies one of the most beautiful truths ever discovered. Let's look closer at what this really means. Imagine two twins. One remains on Earth. The other boards a spacecraft, traveling close to the speed of light, then returns home after a long journey. To the traveler, perhaps only a few years have passed, but to the twin who stayed behind, decades may have gone by. This is called time dilation, and it isn't just theory. It's a measured effect that grows stronger the faster you move, the faster your motion, the slower your inner clock runs, compared to those still behind. It's as though the universe compensates, balancing movement with the passage of time. The twin paradox, as it's known, shows us something extraordinary. That time itself is flexible, personal, and shaped by perspective. Every atom, every particle, every living being carries its own private timeline, woven into the fabric of motion and gravity. Now, think of this in your quietest moments. When you feel time rush by or drag endlessly slow, perhaps it's your own mind, touching that deep relativity. Because even within your brain, perception of time bends. With emotion, attention, and energy, a second of fear feels longer than a minute of joy. Moments of love seem endless. Moments of pain stretch unbearably. Our biology mirrors the universe's physics. We, too, are relative beings, experiencing time, not as a fixed rhythm, but as a dance between perception and motion. Now, let's step into the gentle pull of gravity. The other great sculptor of time, Einstein, showed that gravity is not a force pulling objects downward. It is the bending of space-time itself, caused by mass. A planet, a star, even your own body, warps the space around it, and that curvature tells matter how to move. But here's the quiet marvel. Where space bends, time bends too. The stronger the gravity, the slower time flows. At the surface of Earth, your clock ticks slightly slower than a clock on a distant satellite. The difference is tiny, fractions of a second over years, but crucial without correcting for it. GPS systems would drift miles off course within a single day. This means, as you sit here now, time passes just a little slower for you than it does for someone. Floating high above the atmosphere, gravity gently tugs at your seconds, stretching them ever so slightly. It's strange, isn't it? To think that time itself is heavier near the Earth. And yet, there's comfort in this, because it means the universe is alive with rhythm. Each planet, each star, beating its own unique tempo of existence. Somewhere near a black hole, time crawls so slowly that a few hours there could be centuries out here. At the edge of such gravity, you could watch the universe evolve and fast forward, stars being born, galaxies aging and fading, while your own clock barely ticks. And yet, from your point of view, everything feels calm, normal, as if nothing strange is happening at all. That's relativity's quiet trick. It keeps every observer's experience consistent, even when their timelines differ. There's no absolute time, only relative time, only your time. And so, the more we learn about the universe, the more we realize that time is not a river, flowing the same for all, but a vast, shimmering ocean with countless gentle currents, each carrying its traveler at their own beautiful pace. And perhaps that's what makes existence so tender. No two lives ever unfold in exactly the same rhythm. Your seconds, your moments, your years, they are truly yours, a private melody, played softly. In the grand symphony of space-time, imagine for a moment a pair of clocks, identical, perfectly synchronized. One sits quietly on a table here on Earth. The other is placed aboard a jet, soaring high above the clouds. They begin ticking together, their rhythms matching like a heartbeat. But when the aircraft returns and the clocks are compared again, something strange has happened. They no longer agree. The clock that traveled through the sky is slightly behind by just a few billionths of a second, yet enough to prove that time itself had flowed differently. For the one that moved, this was not imagination, not a dream. It was one of the most delicate, beautifully quiet demonstrations of Einstein's relativity. The experiment was real, conducted in the 1970s by physicists Joseph Haffel and Richard Keating. They placed 4 atomic clocks aboard commercial airliners, flying them eastward and westward around the world, then compared their readings to clocks that had stayed behind at the U.S. Naval Observatory. And when those clocks were brought back together, they confirmed what Einstein had predicted decades earlier. Time moves differently for objects in motion and for objects under different gravitational pulls. To the naked eye, the difference was invisible. But the clocks, those patient keepers of cosmic rhythm, revealed the truth. They had traveled through a different slice of space-time, a clock flying high in the sky, where gravity's pull is weaker, ticks a little faster. Then one down on Earth, a clock racing forward at great speed, ticks a little slower. So when you combine both effects, as the Haffel Keating experiment did, you reveal the subtle bending of time itself. It's humbling, isn't it? That we can hold in our hands. A machine so sensitive, so precise, that it can feel the curvature of reality. Atomic clocks don't tick like the ones we keep at home. They measure time by watching atoms vibrate, each oscillation acting as a perfect metronome for the universe's rhythm. Cesium atoms, for instance, vibrate 9,192,631,770 times per second, each pulse defining 1 second for every scientific measurement on Earth. And when you move one of those atoms faster or place it higher in gravity's field, its rhythm gently changes, revealing time's secret stretch. Let's drift now into another experiment, one even smaller and far more mysterious, far above Earth, in the thin air of the upper atmosphere. Tiny subatomic particles, known as muons, are born. They appear when cosmic rays strike the planet's air, creating showers of short-lived fragments of matter. Muons are unstable. They live for only a few millionths of a second before vanishing into other particles. At their normal speed, they shouldn't survive long enough to reach the Earth's surface. And yet, when scientists measured them, they discovered that countless muons do reach the ground. How? Because they are moving so fast, close to the speed of light, that their internal clocks run more slowly. To us, their lifespans are stretched. To the muons themselves, no time has passed at all. This tiny, ghost-like phenomenon is one of the most powerful pieces of evidence. That time dilation is real. Every moment, high above your head, particles are living longer than they should, not because of magic, but because their motion changes their experience of time. It's breathtaking to think that, right now, this invisible experiment is happening endlessly. In the air around you, particles whispering the secrets of relativity, in the silence between stars. And then there are the experiments, conducted not with atoms or particles, but with satellites, the mechanical stars that orbit Earth every day, GPS satellites floating thousands of kilometers above, carry atomic clocks within them. Those clocks tick a little faster because of the weaker gravity, and a little slower because of their speed. If we didn't adjust for both effects, the GPS system would drift out of sync by about 10 kilometers per day. So every time your phone shows you where you are, the system quietly corrects. For Einstein's relativity, balancing the flow of time between sky and ground, each navigation signal you receive has been shaped by the stretching and folding of space-time itself. Isn't that beautiful? To think that the maps guiding us home depend on the bending of time, a cosmic ballet, translated into our everyday world. Now, let's slow our thoughts and imagine how delicate these measurements truly are to prove that time slows. Even by billionths of a second, scientists had to create clocks so sensitive they could detect the faintest whisper of relativity, At the National Institute of Standards and Technology, physicists built optical lattice clocks that can measure time so precisely they would lose only a single second over the entire age of the universe. With these instruments, they performed another quiet miracle, placing one clock just a few centimeters higher than another and watching as the higher clock ticked ever so slightly faster, only centimeters apart, and yet their times diverged. It's as if even standing on a small hill makes you experience time a fraction differently than someone below. The universe, in its grand scale, is sensitive to the tiniest differences in height, in motion, in gravity. We live surrounded by a soft gradient of time. Each heartbeat, each breath, flows at its own pace within the planet's gentle curve. So what do these experiments tell us? That time, for all its apparent certainty, is not uniform. It stretches, it bends, and it flows differently for every traveler, for every height, for every speed. And yet, it remains perfectly consistent within each person's own frame of reference. To the pilot in the sky, to the muon in flight, to the satellites circling Earth, their clocks feel normal, their seconds steady. It's only when we compare them, side by side, that we notice how differently the universe lets them unfold. And so, in our own lives, perhaps we too can find peace in the idea that time is not a race, nor a single stream, but a gentle fabric, woven differently. For each of us, your seconds, your days, your life's rhythm is your own private time dilation, a reflection of your unique motion through existence. Some moments rush by, others linger softly, but all of them are equally true. In that quiet realization, there's a certain serenity, a feeling that no moment is wasted because every instant is shaped perfectly for the observer who lives it. Time moves through us, not just as seconds on a clock, but as pulses in our veins, as quiet chemical rhythms, whispering inside every cell. We don't just measure time, we feel it. Our bodies know morning and night. They know hunger, they know fatigue, they know when to sleep and when to wake. Even without sunlight, even in deep isolation, the body continues its silent counting, a hidden clock ticking inside our cells. This clock is called the circadian rhythm, a gentle biological wave that repeats roughly every 24 hours. It controls our sleep, our hormones, our body temperature, our emotions, and even how deeply we dream. It is, in many ways, our body's answer to the rotation of the Earth. But what would happen if we could freeze time? Would this rhythm stop? Would the body simply pause, suspended between one heartbeat and the next? Or would life find some secret way to keep whispering forward, even in a world where time no longer flowed? Let's imagine this gently. If time truly froze, everything would be still. Atoms, molecules, light itself. Your heart would not beat. Your breath would not move. Your thoughts would hang motionless in the air. You wouldn't notice, because noticing requires motion, the flow of signals, the passing of microseconds through the neurons of the brain. In a completely frozen moment, there would be no perception of pause, because there would be no you moving through it. It's a strange paradox. To freeze time is also to freeze awareness. To stop motion is to stop the self. And yet, in a gentler sense, we experience small freezes of time every day. When we hold our breath in awe or fear, when we lose ourselves in a moment so beautiful that the rest of the world disappears. Those tiny moments, the ones that feel eternal, are our closest brush with frozen time. They remind us that time's flow is not always constant, that our perception can slow it, stretch it, or make it vanish entirely. Let's look deeper now at what happens inside our bodies when time begins to stretch. Scientists once wondered, could we ever slow biological time? And in small ways, we already do. When you cool the human body, its metabolism slows. Cells divide more slowly. Chemical reactions take longer. Doctors use this during surgeries, lowering a patient's temperature to protect the brain and heart when blood flow must be stopped. In this cool, slowed state, the body uses less oxygen. The cells need less energy. Time, in a biological sense, seems to move more gently. Even in nature, this miracle appears. There are tiny frogs in Alaska and Siberia that freeze solid each winter. Their hearts stop, their blood turns to ice. And yet, when spring returns, they thaw and wake again. For months, they were trapped between moments. Their time paused in a delicate balance between life and death. How do they do it? Inside their cells, they produce natural antifreeze, compounds that protect membranes and proteins from ice damage. They are, in a way, living examples of slowed time, tiny creatures that suspend their biology to survive the cold. And deep in the oceans, some turtles and certain species of fish enter states so slow that they barely move at all, their heartbeats falling to 1 or 2 per minute. Time, for them, is a whisper. So perhaps the body, given the right conditions, can touch the edge of that mystery, not freezing time completely, but bending it, softening its rhythm, until life moves like a dream. Now let's think about time. From within the human mind, inside your brain, there are networks of neurons that record the passage of seconds and minutes. They are not clocks, but patterns, electrical pulses that repeat, like the rhythm of waves at the shore. When you focus deeply, your perception of time narrows. Moments merge together. When you are bored, your mind measures every second, and time seems to drag endlessly. This shows that even inside us, time is subjective. Your biology and your awareness dance together, creating a unique experience of every moment. In one heartbeat, you might feel eternity. In 1 hour, you might feel nothing at all. So what would happen if we could truly slow biological time? Scientists believe it might extend life, not by changing the years we live, but by altering how fast our internal clock ticks. We already know that animals with slower metabolisms often live longer. A mouse's heart beats around 600 times per minute. An elephant's heart only 30. And yet, when you multiply heart rate by lifespan, both reach roughly the same total. A few billion heartbeats per life. It's as if nature gives every creature a certain number of moments, and each chooses how fast to spend them. We, too, are part of that rhythm, perhaps slowing down, breathing more gently, living more mindfully, is our own small way of stretching time, when we walk slowly, when we listen to rain, when we lie beneath the stars, and forget the clock, we expand the space between our thoughts, and in that space, something beautiful happens. Time loosens its grip, life feels longer, and the body, the mind, and the moment align in a calm harmony. That feels almost timeless. So even if we can't truly freeze time, perhaps we can learn to feel what it would be like by slowing down our biology, our thoughts, and our hearts, because sometimes to pause and breathe deeply is to stand still inside eternity. Light, the silent traveler of the universe, it moves faster than anything else we know, 300,000 kilometers every second, crossing oceans, planets, and galaxies. In the blink of an eye, it is the messenger of the cosmos, carrying stories from stars long dead and galaxies billions of years away. But light, for all its motion, knows no time. You see, to a photon, a single particle of light, the journey from one place to another is instantaneous. From our perspective, it might take millions, even billions of years, for starlight to reach us, but for the photon itself, time does not pass. There is no before or after. It leaves the star and arrives in your eye in the same eternal instant, in the frame of light. The universe is frozen. Everything happens at once. It's a thought, so simple and yet so infinite. Imagine a universe where light never ages, where every photon that ever left a star still exists in its eternal now, a frozen thread woven through the fabric of space-time. We often think of light as moving, as racing, as something alive with speed. But for light, there is no motion, because motion requires time, and light is beyond time's reach. So when you gaze at a beam of sunlight, filtering softly through your window, you're seeing something that doesn't experience moments, as you do for the photon. That gentle golden touch is both forever and instantaneous. Now, let's drift into the heart of that mystery. How can something move so fast that it no longer feels time at all? Einstein's theory of relativity tells us that as an object moves faster, its internal clock slows down. For you and me, traveling at ordinary speeds, the difference is imperceptible. But as speed approaches, the speed of light, time itself begins to bend, stretching thinner and thinner until it almost stops. And once you reach light speed, if you somehow could, your experience of time would collapse entirely. The universe around you would be frozen, and your journey would feel timeless. But of course, no object with mass can truly reach that point. Only light, which has no mass, can exist there in a world where space and time have no separation. It's as though light lives on the surface between existence and eternity. Every photon is like a frozen moment, a bridge connecting what was, what is, and what will be. When a star releases its light, that light travels outward forever. Some of it reaches planets. Some escapes into interstellar space. Some falls into black holes. But wherever it goes, it carries with it the exact instant of its creation, unchanged. That means when you look up at the stars tonight, you are not just looking into the past. You are seeing the past itself, preserved perfectly within those photons. They left their stars millions or billions of years ago, and for them, not a single moment has passed. You are touching the frozen light of ancient suns, and perhaps that's the closest we ever come to truly seeing a moment in time, stopped, unmoving, forever suspended in the light that reaches us. Now, let's imagine what it would mean to live like light, to move so swiftly that time no longer touches you. If you could travel at light speed, you could cross the Milky Way in what would feel like an instant, yet for everyone else, millions of years would pass. Your journey would take no time at all for you, but an eternity for others. It's a beautiful paradox. The faster you go, the less time you experience. And so, at the ultimate speed of the universe, time simply stops. In this way, light reveals something gentle and profound, that the universe is full of moments that never truly die. Every photon that has ever existed still carries a piece of its origin, the first light that ever shone, after the birth of the cosmos, the faint glow we call the cosmic microwave background, is still here, still whispering softly through the fabric of space. It has been traveling for nearly 14 billion years, and yet, for those ancient photons, no time has passed. They are eternal witnesses, glimpses of the universe, as it once was, still reaching us in their frozen brilliance. And perhaps, in a poetic way, light reminds us of something about ourselves, that while we move through time, leaving moments behind, those moments never truly vanish. They remain recorded in the light that once touched them. Every sunrise, every smile, every glimmer in someone's eyes, those photons scatter outward, forever traveling, forever carrying the essence of that instant. So maybe nothing is ever truly lost. Perhaps the universe remembers everything in light, and if one day we could see all the light that has ever been, all at once, we might see the entire history of existence, frozen together in one eternal radiant moment. That thought, quiet and infinite, is what makes light the closest thing we have to time standing still. Imagine yourself sitting alone in a perfectly silent room. No sound, no motion, no flicker of change, only stillness. At first, it feels peaceful, a moment of quiet you rarely get in a world that's always rushing somewhere. But then, after a few seconds, you begin to notice something strange. The air isn't truly still. You hear your own breath, your heartbeat, a faint ringing in your ears. The stillness begins to move, and in that realization, you discover one of the most curious truths about human perception. That perfect stillness doesn't really exist. It is something our minds create, an illusion built on how we sense and interpret the world. You see, our brains are pattern seekers. They constantly look for change, for contrast, for difference. When nothing changes, no sound, no motion, no flicker of light, the brain becomes confused. It begins to fill in the gaps, to create motion or sounds that aren't really there. That's why in absolute silence, some people begin to hear whispers, or hums, or the pulse of their own blood. It's not the world moving. It's the mind reminding itself that time still flows. Even when everything seems frozen, our perception continues to dance. The philosopher and scientist Ernst Mach once suggested that motion and stillness are not opposites, but partners, each defined by the other. Without motion, we wouldn't know what stillness means. And so, the perception of stillness is not about a frozen moment in time, but about the delicate balance between awareness and change. When you look at a mountain, it feels eternal, unmoving. Yet, in truth, it shifts by millimeters each year, its rocks weathering, its snow melting, its very atoms vibrating quietly. Stillness, then, is simply motion so subtle that our senses can no longer feel it. Now, let's explore how the brain experiences this illusion more deeply. Our sense of time is built not on clocks, but on change, on how often we notice something new. If you sit in a quiet room and nothing happens, your brain's internal sense of time begins to slow down. Minutes stretch into what feels like hours. This is called temporal perception drift, and it's a fascinating psychological phenomenon. Scientists studying astronauts, who often experience long periods of silence and stillness in space, found that they lose track of time. Without movement or regular cues, their internal rhythm shifts, as if their minds are gently unanchoring from the flow of moments. When stillness surrounds us, our thoughts begin to stretch, the mind wanders, and time loses its structure. Perhaps that's why stillness feels so calming, and also so strange. It quiets the body, but amplifies the inner world. Even when the outer world is still, our inner world keeps moving. A stream of memories, emotions, and dreams flowing quietly behind closed eyes. Close your eyes for a moment and think about how time feels in that darkness. It doesn't tick. It doesn't count. It drifts. In stillness, you are not outside of time. You are within it. It's almost like floating, not forward, not backward, just suspended. And perhaps that's why meditation, deep sleep, or slow breathing all feel timeless. They pull us into the same state, where time loses meaning, not because it stops, but because our minds stop measuring it. This is the true nature of stillness, a gentle surrender to the rhythm of existence without needing to count its beats. Let's imagine for a moment what would happen if time truly stopped, if the world around us froze completely. Would we even notice? If your thoughts, your breath, and even your neurons froze mid-spark, you wouldn't be there to feel it. Stillness, in its absolute form, cannot be perceived because perception itself requires change. To see, light must move into your eyes. To hear, air must vibrate. To think, electrical impulses must travel between neurons. If all motion ceased, awareness would vanish with it. So the stillness we know, the kind we experience, is not the absence of motion, but the slowing of it. It's a place where movement becomes so gentle, so subtle, that it blends into eternity. Artists, musicians, and scientists alike have tried to capture this mystery. The painter freezes a single moment, a wave suspended mid-crest. A dancer paused in midair, and in that frozen beauty, we feel the flow of time more strongly than ever. The composer writes a single, sustained note, a vibration held long enough to make us aware of its eventual fading. In stillness, we become aware of time itself. It's not the absence of time we feel, but our closeness to it. And perhaps That's what makes stillness so sacred. It's the thin veil between being and nothingness, between motion and rest, between moment and eternity. When we slow down, when we breathe, and allow stillness to fill us, we are not escaping time. We are touching it gently. Every breath, every heartbeat, every pause becomes a soft reminder that even when the world seems still, life quietly continues beneath it. So when you sit in silence tonight and feel the still air around you, remember, you are not frozen. You are simply aligned with the quiet rhythm of the universe. That is the perception of stillness, the meeting point of movement and peace. If we could shrink ourselves down, smaller than dust, smaller than atoms, smaller even than light itself, we would find a world that feels unlike anything we know, a place where things don't move in lines, but in possibilities, where particles flicker in and out of existence, as though unsure if they truly belong here. This is the quantum world, the hidden foundation beneath everything that exists. And here, the dream of freezing time faces its most beautiful and most impossible challenge. You see, in the quantum realm, nothing ever truly rests, even when a system is cooled to what we call absolute zero, the coldest possible temperature in the universe. Its particles never become completely still. They continue to vibrate softly, gently, imperceptibly, because of something called zero-point energy. It's the faint whisper of motion that never dies. Scientists once believed that if you could remove all heat, all energy, you could stop motion entirely and perhaps pause time itself. But the quantum world told a different story. At absolute zero, particles still jitter in their invisible cages. They cannot be pinned down, cannot be held perfectly still, because to do so would violate one of nature's deepest rules, the Heisenberg uncertainty principle. This principle says you can never know both a particle's position and its momentum at the same time. If you try to measure where something is with absolute precision, you lose all knowledge of how it's moving. And if you measure how fast it moves, you can no longer say exactly where it is. This means that at the smallest scales, stillness becomes impossible to define. Every particle, even when it seems frozen, exists in a cloud of uncertainty, a shimmering blur of possibilities. So even if time were somehow paused, the quantum world would continue to flicker underneath. The universe, at its deepest level, refuses to be completely still. It's as though there's a heartbeat woven into the fabric of existence itself, a pulse that never stops, never freezes, never fades. Now let's look closer at how this eternal motion shapes reality itself. Think about an atom, a tiny solar system with electrons orbiting around a nucleus. You might imagine that if time froze, those electrons would stop spinning, stop moving entirely. But in truth, they are never in one place to begin with. Electrons don't move like planets. They exist as clouds of probability, their location smeared across space, like a mist of potential. This means that at every instant, the universe isn't fixed. It's constantly exploring possibilities, reshaping itself in ways we can never fully see. Quantum physicists call this the wave function, a mathematical description of every possible state a particle could be in all at once. Only when we observe it does the wave function collapse, and the particle chooses one reality to become. So, in a way, our very act of observation brings stillness into being, momentarily fixing what was once fluid and uncertain. That is the strange truth of quantum time. At the smallest scales, the world does not tick like a clock. There are no seconds, no continuous flow, only tiny jumps, fluctuations, and quantum leaps. Time itself seems to appear and vanish in trembling pulses of probability. Even space is not smooth, but granular, woven from unimaginably tiny units, called Planck lengths and Planck times. Below those limits, our familiar ideas of distance and duration simply dissolve. And so, the closer we look, the more we realize that time cannot be frozen, because it doesn't flow smoothly enough to be stopped. It flickers, it hums, it trembles at the edge of existence. Now, imagine yourself standing on the edge of that quantum ocean, looking down into the endless dance of uncertainty. It's not chaotic. It's not wild. It's breathtakingly precise. A choreography so intricate that even randomness has meaning. Every vibration, every flicker of energy is part of a cosmic rhythm that gives rise to everything we see: atoms, molecules, life, and time itself. If we could somehow freeze all of that, every quantum pulse, every vibration, we would erase the very structure of existence. Without motion, there would be no heat, no sound, no consciousness, no being. Stillness, at that level, is non-existence. And yet, within that eternal motion, there is peace, a quietness so profound that it feels like stillness, like the gentle hum of the universe, steady and constant beneath the noise of life. The poet William Blake once wrote, "To see a world in a grain of sand, an eternity in an hour." Perhaps he was unknowingly describing the quantum truth that within the smallest vibration, the entire universe is alive, and within every fleeting moment, eternity unfolds. So when you think of freezing time, remember, time at its smallest scale is already moving in whispers. You can never stop it completely, but you can learn to feel its rhythm, to slow your breath, to quiet your thoughts, until you move in harmony with the hum of everything. That is the true quantum stillness, not the absence of motion, but the acceptance of constant change. The world will never truly freeze, but you, in your calm, in your quiet, can touch the peace that lies just beneath it. Close your eyes and imagine a single snowflake frozen in midair. You can see it, the delicate crystal edges, the faint shimmer of light, the perfect stillness, suspended between falling and landing. You can hold this image for as long as you wish. It does not melt. It does not fall. It simply is. That is the quiet power of imagination. In our minds, we can do what the laws of physics forbid. We can pause a sunset, stretch a single second into eternity, or replay a cherished memory again and again without it ever changing. Our brains, these soft and silent universes of thought, are not bound entirely by time's steady rhythm. When you imagine something, a scene, a place, a face, you are creating a frozen moment, a mental photograph that exists beyond the ticking of the clock. In the physical world, Moments vanish instantly. They pass through us like waves. But in imagination, we hold them, we shape them, we bring them back to life. This ability has guided humanity through every age of discovery and art. When ancient storytellers gathered around fires, they imagined worlds unseen, creatures, spirits, gods, and stars. When scientists look at the night sky, they too imagine, but their stories unfold through equations and dreams of reality. Einstein himself once said that imagination is more important than knowledge, because knowledge tells us what is, but imagination shows us what might be. In our inner world, we are not limited by time or place. A single thought can travel to the past, revisit a memory, or leap into the distant future. You can close your eyes right now and walk through your childhood home, feel the same walls, smell the same air, or you can imagine yourself standing beneath alien stars on a planet that no telescope has ever seen. The imagination is the closest thing we possess to freezing time. It allows us to visit moments long gone and to create moments that have never yet existed. Let's drift a little deeper now into how imagination and time are woven together inside the human brain. When we recall a memory, say, a conversation from years ago, our brains do not simply play it back like a recording. Instead, they reconstruct it, rebuilding the scene, recoloring it with emotion, reshaping it with understanding. Each time we remember something, we create a slightly new version of it, fresh, alive, and timeless. This is one of the reasons that imagination feels endless. Every memory, every dream is a bridge across time, a frozen image we can return to, but one that subtly changes each time we look at it. And yet, that change doesn't ruin the illusion. In fact, it gives it life. Our minds are time travelers and also time sculptors. When you imagine the future, you're not just predicting, you're creating mental simulations, playing out events that haven't yet happened. Neuroscientists call this the default mode network, a set of brain regions that activate when we dream, plan, or drift into thought. It's the same system that builds our inner stories. Inside this network, time is fluid. You can think of it as a river that bends back on itself, sometimes pooling in memories, sometimes branching into possibilities. And while your body stays anchored in the present, your mind floats freely through time's current. That's why imagination feels so restful. It is the only state of consciousness where time's pressure disappears. A minute of daydreaming might feel like an hour, and an hour of creative flow can pass in what feels like seconds. We've all felt this, losing ourselves in a story, in music, in a quiet reverie. It's the mind's way of pausing the outer world and entering the inner one, a world that listens to its own rhythm. When artists paint, when composers write, when poets dream, they are not only creating beauty, they are suspending time within their own consciousness. Every brushstroke, every word becomes a frozen echo of something infinite. Now, let's wander to the edge of imagination, to where it meets the mysteries of existence. Our minds do more than just picture stillness. They feel it. When you imagine stopping time, your heart slows, your breath deepens, and your body relaxes, as though your imagination has gently convinced your biology to follow. This is not fantasy. its physiology. Studies on visualization and mindfulness show that imagined experiences activate the same brain regions as real ones. When you picture yourself floating weightlessly, your brain's sensory and motor areas light up as though you truly are. Imagination, in a quiet and scientific sense, can bend time within the mind. It can make moments expand, make worries fade, make stillness feel eternal. And that is why so many cultures have used imagination as a path to inner peace through stories, meditation, and dreams. In the gentle realm of the mind, you can walk through the stars, or return to the warmth of childhood, or drift through a world where time stands perfectly still. The human imagination is our refuge from the unstoppable flow of life. It allows us to pause, not by freezing time, but by stepping outside of it. And maybe that's the truest magic of all, because every great discovery, every invention, every act of kindness or creation begins first as a quiet image in someone's mind, an imagined moment that waits patiently to become real. So when you dream tonight, remember, you are not escaping the world. You are exploring its deepest dimension. The imagination is not just thought, it's a universe, as seen through the eyes of the soul. And in its soft, timeless glow, you might just find that you can freeze time, not out there, but within. There comes a moment after all our wondering, after all our questions about freezing, bending, or stopping time, when we simply sit quietly and realize that perhaps the flow of time itself is not our enemy, but our teacher. Time is a silent current that carries us forward, moment by moment, heartbeat by heartbeat. It does not rush, and it does not pause. It simply moves, as it always has. Every sunrise, every sigh, every memory is a soft ripple upon its surface. And though we spend our lives trying to hold on to moments, to keep them still, to make them last, they always slip gently through our fingers. But what if that isn't something to mourn? What if the beauty of time is in its very passing? A river that does not flow becomes a stagnant pool. A song that never ends loses its melody. A heart that never changes forgets how to feel. So too with time. It moves, not to take things away from us, but to give us new things to hold. Each breath you take is a gift you could not have known if time had ever stood still. In its flow, you experience love, growth, and a quiet unfolding of life itself. And so, perhaps, the gentlest way to understand time is not to wish for it to stop, but to thank it for carrying us through. Now, imagine time not as a ticking clock, but as a soft breeze moving through a forest. You cannot see it, but you can feel it in the way the leaves tremble, in the way light shifts through the branches. It touches everything, but holds on to nothing. That is how we, too, are meant to live. Each moment, each experience is like a leaf drifting past us, beautiful, temporary, and perfect in its motion. We often fear change because we think it means loss. But change is the breath of time, the way life renews itself. Look at the seasons. Spring does not mourn the melting of winter, nor does summer fight against autumn's fall. Each accepts its moment. Each bows gracefully to the next. If we could learn to move like that, to accept that everything, even our own moments of stillness, must eventually pass, we might discover a peace beyond measure. You see, acceptance does not mean surrender. It means trust. Trust that the universe knows what it is doing, that each tick of the clock is not a thief, but a guide showing us where to look next and reminding us to be present right now, because this moment, the one you are hearing, the one you are feeling, will never come again. And that is precisely what makes it so precious. Let's pause now and breathe together, slowly, deeply. Inhale and feel time enter you, the air, the sound, the now. Exhale and let it flow through you, softly, gently, without resistance. You are not separate from time. You are part of it. You are it. The atoms in your body once danced inside stars. They lived other lives, in other forms, long before you were born. And someday they will drift onward again, back into the universe, to become something new. Nothing ever truly ends. It only changes shape. So when we speak of freezing time, perhaps what we truly seek is to feel time more deeply, to slow enough to notice its beauty as it passes. We cannot stop the current, but we can float within it. We can choose to find comfort in its rhythm and gratitude in its gifts. Time is not a force to conquer. It is a song to listen to. And as it plays, you are both the listener and the melody itself. So, my dear dreamer, as this quiet night drifts onward, may you rest in that gentle truth. Time flows, and so do you. Each moment new, each breath timeless. May your dreams be calm, your heart unhurried, and your mind at peace with the endless river of existence. Good night and goodbye until time brings us together once more